In the third question, we have integral from 3 to 2 x square dx. How do we do that? Well, to evaluate this integral using definite area as limit of sum. So the result is important. First of all, a to b fx dx, this integral is equal to what? As limit of sum, limit n tends to infinity, b minus a upon n is what I have. This is the value of h, and in the other bracket we have f of a plus h plus dot 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 plus f of a plus n minus 1 h, this bracket, and then a square bracket. B minus a upon n is equal to h. This is what I know, right? So once you are okay with this formula, then I can apply this formula on this integral I, which is integral of 2 to 3 x square dx. The important thing to observe here is the values of a is 2, b is 3, okay. Fx, as you can see, is x square, and the value of h is b minus a upon n. B minus a upon n, what is that equal to? B minus a is 3 minus 2, so h is equal to 1 upon n. This h is equal to 1 upon n. That's what you observe over here. Is that okay? Yes? Okay. Once you are through with this, then I can apply that formula with the help of these values on this integral and simplifying this integral. Therefore, I becomes equal to what? This definite integral can be written as a summation, and using that, limit n tends to infinity, b minus a upon n. B minus a upon n is 1 by n. In the other bracket, you have f of a plus h. F of a is 2, so this is f of 2 plus f of 2 plus h plus f of 2 plus 2h plus dot 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 f of, last term will be 2 plus n minus 1h. N minus 1 h is what I get, bracket closed. This is what you'll have. Is that okay? Yes. So this becomes now limit n tends to infinity, which is okay. 1 by n is also okay. And in the bracket, what do we have? F of 2. F of 2 becomes 2 square. 2 plus h square. 2 plus 2h square plus dot 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 2 plus n minus 1 h and its square in this bracket. Now adding these terms using concepts of sequence and series is the key, right? So let's try to add these terms. Limit n tends to infinity, 1 by n is okay, and this becomes 2 square, okay. What about this term over here? Let's take a look at this term. This is 2 plus h whole square, which will give us 2 square, and it will also give me a h square. It will also give me 2 times 2h plus what else? Next, let's take a look at this. So this will be 2 square again, plus the other terms square will be 2 square h square plus 2 into a into b. And what will that be? So 2 into a into b is, what you can say? So that will be 4h, is it? Or yes, 4h. Let's write it as 4h for that matter, right? Okay, what else? So 2 into 4h is what I'll get, plus what about the next term? If you take a look at the next term, this will be 2 plus 3h square. So that will be, if you observe carefully, these are 2 squares will come out. H square, 2 square h square, and what you'll get is 3 square h square over there. 2 into 2h, 2 into 4h, and next will be 2 into 6h actually. That's the term that you should be looking out for. But then dot 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 dot, the last term will also look like this. 2 square plus n minus 1 square h square plus, what do we have over here is 2 into n minus 1h. This is what you'll get. That's a complete expression. Yes, there's a round bracket over here as well. Yes, this is what you have. Now let's take a look at this complete summation and try to take out similar terms together. Limit n tends to infinity is okay. 1 upon n is also okay. In the bracket, what do we have? So observe, 2 square, 2 square, 2 square is there in each and every term. So this will become 2 square times n. Since this is there in each and every term. This is the first thing. Then you have h square times 1, h square times 2 square, h square times n minus 1 square, which will tell me, okay, h square, along with h square you have 1 square, 2 square, dot dot dot, n minus 1, this is n minus 1 square. In the bracket you will have n minus 1 and its square over there, right? This is the term over here. This is that second term. What else? What about this third term? 2 into 2 into h, 2 into 4 into h, 2 into 6 into h, 2 into n minus 1 into h. So if you observe, 2 into 2 will come out common, 2 into 2, this will leave a 2h, this will leave a h, this will leave a 3h, yes? So what you can take out is 2 into h can come out common, that is 4h. If 4h comes out common, what will remain is 1, 2, 3 from the next term, tuck, tuck, tuck. And similarly, you will have 2 into h comes out common, this will be n minus 1. These are sum of n minus 1 terms. That's the complete square bracket close. 4h times 1 to n minus 1. This is 1 square up till n minus 1 square, right? You can see the symmetry over there. Yes, you can clearly see the symmetry over there. Therefore, I further becomes equal to limit n tends to infinity. Now, we just have to simplify that whole expression. Limit n tends to infinity, 1 by n is okay. In the square brackets, this becomes 2 power, that was not 2 power n, this was 2 power 2. This is not 2 power n, this is 2 power 2 actually. 2 square times n, which is 4n. And you have h square times sum of squares of first n minus 1 natural numbers. Now recall, I'll write one result over here. 1 square plus 2 square plus dot 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 up till n square is equal to n times n plus 1 to n plus 1 by 6. If you remember this, then you can see that instead of n we are going up till n minus 1, right? So n will be replaced with n minus 1. This will become n minus 1 plus 1, 2 times n minus 1 plus 1 is what I get over there. So along with h square you get n minus 1. Then you get n minus 1 plus 1, which is n. Then you get 2 times n minus 1, 2n minus 2 plus 1, which is 2n minus 1 upon 6. That's the second term. This term has been simplified over here. What about this third? This is 4h times 1 to n minus 1. The sum is 1 to n minus 1. The sum of first n natural numbers is n times n plus 1 upon 2. So this becomes n minus 1 times n minus 1 plus 1, which is n by 2. This is what you get. Is that okay? Yes. Now, this tells me I is equal to limit n tends to infinity. Okay, that's the first thing. And 1 by n is already there. We can take that 1 by n inside in the square bracket. What do we get? 4n upon n is 4 plus h square is 1 by n square. There's a 1 by n as well. So 1 by n cube is what I'll get. And this will get cancelled. So n minus 1 to n minus 1. We could multiply them together as well. We can multiply them together. Yes, let's multiply them together. This is 2n square minus 2n minus n was minus 3n plus 1 upon, what do we have? Here is a 6 in the denominator. H square was 1 by n square. This 1 by n gets cancelled with this. So you get a n square in the denominator. Right? What else? Plus 1 by n and this n will get cancelled. 4 into 1 by n times this. So what do you get? 4 by 2 is 2. N minus 1 upon n is what I get from here. Right? This is what I get. Is that okay? Yes, that looks simple. Yes. Now, limit can be applied, and what do you get? Limit n tends to infinity, this will be 4 plus, what will this be? 2n square upon 6n square, that will be 1 by 3. 3n upon 6n square will be 0. This will be 1 by 2n, which will be tending to 0. 1 upon 6n square will be 0. What about this? This will be 2. 1 minus 1 upon n will be again 0. So this is what you get. 4 plus 2 is 6 plus 1 by 3. This is 19 by 3. That's my correct answer for this particular question, right? That's the final answer, and that's the complete solution for this question, as you can see over here.